If I were to make that a gas, now the molecules are going to be moving all around and bouncing off the sides. And if I were to make it a liquid, what does a liquid look like? Well, they're not just going to be vibrating in place. They're going to be sliding past one another, and as they do that, they're going to fill the container. And the simulation is kind of slow, but eventually what will happen is all the liquid is going to settle on the bottom. And so what would that look like with oxygen, or excuse me, let's go to water. What does water look like? Well, if it's a solid, it's going to form ice. It's still going to vibrate, still going to move, but it's going to form these nice hydrogen bonds. As we make it a liquid, then they'll slide past one another and it'd fill up the container. And then if we make it a gas, it's going to be bouncing out throughout that whole container. And this is a cool simulation, and we can play with it. And so let's play with this. For example, what things are going to change us from one matter to another? Well, let's look what happens if we start to heat up the neon. So as we start to heat up the neon or add heat to it, it's going to start turning, first of all, into a liquid. And then if we keep heating it, it's eventually going to turn into a gas. And so as we add temperature, then we can change it from one phase to another. If I add some ice right now, I'm going to cool it down. What's that eventually going to become? It's eventually going to become a liquid, and then it'll become a solid if I let it sit long enough. And so temperature is one thing that can affect the phases of matter. What's another thing that could do it is pressure. And so if I start to apply pressure on here, I can change the phases of matter as well. But I have to be careful. If I push it too hard, I'm going to explode my container. Okay, so let's go back to talking about matter. As we move into high school then, we should really talk about the parts of an atom. And so what's an atom made up of? It's made up of a nucleus, and that nucleus is going to have two subatomic particles in it. We're going to have protons, those are red here, and they're going to be positive in nature. And then we're going to have neutrons, which are going to be neutral. They don't have any kind of a charge. Those are going to be in the nucleus, and it's incredibly small. So like in a football stadium, if you think of that, the size of an atom, if we could blow up an atom to that size, the nucleus is really only going to be about the size of a ping pong ball, right in the middle on the 50-yard line. So again, nucleus is incredibly small. What goes around the nucleus, what's the rest of the atom? It's mostly made of electrons. It's these clouds of probability where the electrons may or may not exist, and those are going to be negative in charge. And so those are the three parts of an atom. We organize the atoms that we have identified on our periodic table, and it's organized like this. The first one's going to be hydrogen. And then as we move to the right and then down, we're going to increase the number of protons. And so we know that hydrogen is going to have one proton because it has an atomic number of 1. Helium was what we were just looking on the previous slide. Helium is going to have an atomic number of 2. That means it has 2 protons. And so you can just look anywhere on the periodic table. Gold, for example, at 79, we know that it has exactly 79 protons in the nucleus. How else is the periodic table organized? Well, you'll find that it's going to have these columns. And those columns are related to properties, but they're more related to the outer electron states. In other words, the electrons on the outer level. And so there's cool things we can find, like all of these are going to be noble gases. In other words, these are going to be stable gases like helium, neon, argon, krypton. We can put all these in a tube and make a neon light. We might find if we look here that copper, silver, and gold, you know that those are all going to have similar properties, and that's because of those electrons on the outer level. Or if we were to look at these in this first column, hydrogen is going to be a gas, but everything else is going to be a solid, and it's going to be highly reactive. So if we mix lithium, sodium, or potassium with water, we're going to get an explosion. And so again, looking vertically is going to tell us a lot about the behavior of the atoms, and that's due to their outer electron levels. So what makes matter matter, going back to what they should have talked about in elementary school, it's going to be these electrons on the outer level. And so why is metal conduct electricity? Why is it shiny or wood not? It has to do with those electrons on the outer level. And in fact, when I'm touching my hands together and pushing them, they're not really touching each other. It's the electrons that are hovering kind of over each other at this really microscopic level. And so one thing you should know is that what makes matter behave the way they do is these electrical forces. And so they try to become stable both in their electron states outside and then inside. So there's a term you should become familiar with. It's called binding energy. What does that mean? Well, reactants and products are going to have different amounts of energy. And so in a quick reaction, we've got oxygen and hydrogen, and they're inherently going to be unstable gases, and they're going to combine to form something called water. What's a real-world example of that? The Hindenburg, when it started on fire, the hydrogen was burning. In other words, the hydrogen is mixing with the oxygen in the air, and we got a huge amount of energy. That energy is called binding energy. It's the difference between the energy of an unstable molecule and one that's stable. And so this is an exergonic reaction. We're losing energy. And where's that energy going? It's being released as heat and light. Now, we have to put a little spark into that. We call this activation energy. You have to put some energy into it to get it going. But that's going to be binding energy. If we reverse that, this is water right here that we're running electricity through. And so what we're doing is adding energy to it. Now we're adding energy to the water. And as we do that, we can break that water back into its oxygen and hydrogen. And what's neat about this experiment is you're going to have twice as much hydrogen gas, because there's going to be 2 atoms of hydrogen for 1 atom of oxygen. But we have to put energy into the system. What's an example of that? Well, leaves are doing that. They're taking energy from light and storing it in their food. Well, who are they making the food for? Themselves. They can then break that down and they can release that binding energy as energy to grow. And so that's the structure and the function of matter, or properties of matter, and I hope that was helpful.